Good morning, Paris. No, it's not morning when we are not in Paris, but I always wanted to say that. My name is Gil, and I'm the CTO of Comsec Global. And Comsec is an Israeli company, the most veteran and the biggest company in Israel of information security. I started my career as a military hacker. And first I was a programmer, a .NET developer, and then I became a military hacker in the IDF. I cannot tell you where, because then I have to kill you, and you are a lot of people, and I cannot cope with each and every one of you, but so I'll just spare the details. I've been a hacker for 12 years now. I started my career as a application penetration tester. Now I hack pretty much everything, or most of the things. And I'm the lead hacker, chief technology officer of Comsec. And we are a medium company, 150 consultants, 600 clients in 22 countries. And we do a lot of interesting stuff. And just a second. We do a lot of interesting stuff, such as penetration test, security development lifecycle, compliance, ISO, PCI DSS, and also some advanced services such as red teaming and ethical hacking. And we have some guys from Comsec here. Raise your hand. So if you want to ask them questions later on, please do. Among the other things that we occasionally come up with something interesting, and we move on with research. And this was the case with the next presentation I'm going to show you about Windows name pipes. So this is something that I personally came up with in one of our clients. And when we further investigated it, we saw that nobody is aware that there is such an interface. And this is why I called this presentation the forgotten interface. And nobody knows that it actually exists. And now I'm going to tell you about it. So let's start with some key terms. Inter-process communication. This is a process or interface that allows multiple processes to communicate. You can do it in multiple ways. You can do it using sockets, plain IP and port. You can do it with files, databases, and you can also do it with inter-process communication interfaces. Inter-process communication, it categorizes the different users to clients and servers. But most of the times, they are both. So the process can be both an IPC client and an IPC server that serves information to other processes. And one IPC, inter-process communication implementation, is called Windows named pipes. Who is familiar with Windows named pipes? Raise your hand. Not many. This is exactly what I've witnessed when I started this research. And even if you know Windows named pipes, you won't know what I'm going to show you later on. So named pipes is an interface that allows processes to communicate. It can be one way or duplex, half duplex or full duplex. And it utilizes a unique file system that is called NPFS, named pipe file system. And it allows, in the default configuration of it, that any process can access any named pipe. This is the default configuration. And all instances of a named pipe share the same pipe name. Each process has a pipe, and this is the pipe server, and multiple other processes can connect to it, just like sockets, and this is called a pipe instance, and they all share the same name, similar to socket. So you have half duplex or full duplex, you have byte-oriented or packet-oriented, local or network. Windows named pipes is accessible through network with some preconditions. And this is something that almost nobody knows. When I first started this research, I found that some people know what named pipes are, but they also think that inter-process communication is local only. And I found out that this is not the case. You can actually access named pipes remotely. How? Using one of these two services, SMB, port number 445, or RPC, port 135. RPC, if you don't know what it is, it's a remote protocol call. This is a standard protocol in Windows that allows one program to invoke a service in another program. And it utilizes the port number 135, TCP or UDP. And DCRPC, this is a variant of RPC, Distributed Computing Environment Remote Protocol. This is actually lets the programmer think that the procedure or the service is local when actually it is a remote service. So this is just a variant of RPC. SMB, server message block. Probably most of you know it with file shares. You can see the different file shares. So if you have any open SMB port or file share, like $, for example, then theoretically you can use it also to connect to named pipes. So there are actually two types of named pipes. One is named pipes that has specific names. The other is unnamed or anonymous pipes, not the anonymous with this small icon there, but just general anonymous pipes. And this is actually named pipes that are unnamed. When you open it, you don't assign the name to it, and it closes once the process is over. But it actually it is implemented using random names.
Oui, bonjour, excusez-moi, c'est une petite urgence. Est-ce que Julien Turpin est dans l'assistance? Julien Turpin, vous pouvez venir avec moi, s'il vous plaît? Merci.
So there are two types, named pipes and unnamed pipes, but I'm going to focus now only on the named pipes, because this is what we find interesting. The unnamed pipes, the anonymous pipes, cannot be you cannot communicate with it remotely, only locally. And we researched the regular named pipes, the one that had name, because you can connect it, you can connect remotely to it. So how can you connect to a named pipe? Let's see some interesting utilities. First, you use NPFS, named pipe file system, and you cannot mount it using a regular SMB connection. You cannot just write down / IP address / pipe and pipe name. This is the way you connect to a pipe, but you cannot do it in your Windows run, your regular Windows command or mount. You need to do it using either programmatically or dedicated tools that allows you to talk to named pipes. And I'm going to show you a very nice one. And this is the tool that we were using. This is called IO Ninja, Input-Output Ninja. This is the Swiss Army knife for communication of all kinds. You can also use it as a socket communication tool, just a plain socket or files. But the thing that really makes this tool very unique and strong is its ability to communicate to named pipes and also to sniff named pipes content. So this is how it looks like. And this is how communication to named pipes looks like. You can see that it is unencrypted, obviously. SMB and RPC are unencrypted. So you can see that a named pipe communication looks like SMB when you look at it at Wireshark. But what are the restrictions of named pipe communications? So there are two main restrictions. One is ACLs, just regular access control lists, like you use in files. This is the reason that it uses these ACLs is that it actually uses the same security descriptors in Windows. And you can assign specific ACLs for specific users to a specific named pipe. But again, the default configuration of a named pipe is that if you don't assign a default ACL, a specific ACL for a specific user, anyone can connect. And anonymously. Very nice for hackers. And if you want to enumerate a specific named pipe ACL, this is how it looked like. You can see that in this specific name pipe, init shutdown, it's called. This is a Windows name pipe. You can see that everyone can connect anonymously. There are other tools as well, third-party tools. This is an obsolete and abandoned utility that is called Beyond Security Pipe Security Editor. It used to work in Windows XP, but it's not relevant anymore unless you use Windows XP, and then it's not good for you. And another limitation of named pipes, unlike sockets and any other interface you are familiar with, is maximum instances. Each connection to a named pipe is called a named pipe instance. And when a client connects to a named pipe, it actually increases a counter that can limit the number of maximum instances. So here you can see the different named pipes on the left, and on the right you can see the maximum number of instances. -1 means no limitation, but if there is a limitation, then once the number of instances it reaches the number of instances, it won't let you connect to this named pipe. So this is something unique to named pipes in connection limitations or instances limitations. So how can you enumerate a named pipe? There are several tools. Most of them, by the way, are sysinternals utilities. So here you can see this is the most used tool for named pipes. This is called a pipe list. And you can see that this utility just enumerates the different named pipes, their instances, and max instances. So the Princeton I was showing you was actually the output of this utility, pipe list. Another useful utility is called pipe ACL. This is also from sysinternal, and this shows you the permissions. So the permissions I showed you earlier, this is actually this utility's output. And there are other utilities as well. In Metasploit, when we first started the research, we searched for information about named pipes, and we found almost nothing, except for a small plugin in Metasploit that is called Pipe Auditor. There are actually two plugins, Pipe Auditor and Pipe DC RPC Auditor. The SMB version is Pipe Auditor, and the RPC version is the other one, that allows you to remotely enumerate for named pipes. But this is largely unused and not that familiar. It's pretty small utility that I never heard of. And we use Metasploit in ComSec, obviously, but people don't know that named pipes exist, and they don't know that it can be connected remotely and enumerated. So obviously, no one searches for this tool. But we find it pretty useful. So how can you sniff named pipe content? Yet again, IONinja. IONinja, they have a pretty new module that allows you to actually activate it like Wireshark for named pipes. So you activate IONinja as an administrator, and then you start it. You can see that I assigned a star filter, which means just get everything for all of the named pipes that you can read. And then I immediately start to see some information about these named pipes. Request and response. And here's another bigger example. You can see the actual content, which is obviously not encrypted. And once you have this nice interface that no one is aware of, the logical thing to do, and what we started to do in our research, is to fuzz it. And if you don't know what fuzzing is, fuzzing is fuzz testing. This is an automated software testing technique that involves providing invalid, unexpected, or random data to input to computer programs. It sounds a little bit like QA, but it actually is doing some different tests and different techniques that allows you to find vulnerabilities and bugs that cannot be found in other ways. So usually you perform fuzzing with fuzzers, which is automatic fuzzing tools. And if you have an iPhone, for example, and if you jailbroken it, most chances are that the bug and the vulnerability that allowed jailbreaking was found using fuzzing utilities. And there are two types of fuzzing: dumb or black box fuzzing, when you just bombard the interface without knowing almost anything about this interface. Just send random strings and random numbers and bytes, etc. And smart fuzzing, where you actually understand the expected input and the purpose of each field, and you start to analyze it. During our research, we only performed dumb fuzzing, and we were able to find a very nice demo I'm going to show you in a short while, using only dumb fuzzing. So imagine what you could do with smart fuzzing, and especially if you connect it to a well-known fuzzing frameworks like Pitch. This is something we haven't done yet. So the utility that we used is just a small fuzzer tool that we found. This is the tool. It is written more than 10 years ago, and a programmer actually wrote it as a local fuzzer only, because he also didn't know that it is possible to connect to a named pipe remotely. So we slightly modified it, and we start fuzzing using this nice utility. And soon after, just a few days after, we found this vulnerability that I'm going to show you in the live demo. So what is the actual impact of this interface? So many pieces of software work with hidden or undocumented APIs, and named pipes is one of them. And the forgotten nature of named pipes, when I asked you who knows named pipes, I saw just a few hands going up, so obviously this is a forgotten interface. It leaves you an uncharted territory of socket-like interface that can contain vulnerabilities. Any vulnerability that can be found in a socket, remote code execution, buffer overflow, denial of service, or injections even, can be found in named pipes as well, because you can do pretty much whatever you want in a named pipe. You can, for example, create a XML-like, a web service-like named pipe, and then any application, a regular application vulnerability, can be relevant to named pipe as well. But the more common or severe one is buffer overflow, denial of service, and in some cases, remote code execution. So if a named pipe allows remote access, you can have a remote denial of service or remote code execution. And if this is not a well-known or there is no patch, you can have 0 days of vulnerabilities. Have you heard of the recent WannaCry just a month ago? So imagine that someone would find a vulnerability in a Windows named pipe that would allow anyone to remotely execute commands in Windows. So you would have a WannaCry 2 version that utilizes named pipes vulnerability. Game over. Remote code execution or remote DOS. So let's see a case study of two small utilities that we found vulnerable to the remote denial of service and even remote command injection using named pipes. So we found that two programs were vulnerable. One is QBittorrent. This is a cross-platform client for BitTorrent protocol. It's open source and written in C++, which hackers like because there is buffer overflow in C++. And the other one is SugarSync. This is a cloud service that allows synchronizing files. And this is the client of this cloud service. It's used for backups, etc. There are many similar services as well. And this is cross-platform, but we only focused on the Windows version because obviously Windows named pipes exist only on Windows. So both applications uses something that is called Qt framework. And this framework, this is a cross-platform framework for developers, and it is embedded in many applications, including mobiles and Windows applications. And we found that both applications using something that is called Qt single app. That this is probably for making sure that there is only one instance of this application running. And we fuzzed it using the script I was showing you. And then we managed to remotely crash the programs. And in QBittorrent, there is also a possibility of remote command injection. So let's see a live demo. I'm now silently praying to the demo gods. So this is my virtual machine. You can see that this is my IP address. And now I'm going to activate qBittorrent. And after activating qBittorrent, you can see that I have this named pipe, qt single app qbito, and something that looks like a random number. So this is the named pipe that I'm going to remotely connect to. And I'm going to do it using IO Ninja. So here, I will create a file stream that allows you to connect two named pipes. The name is a little bit confusing, but this is actually used for named pipes. So here, you can see that I'm putting the IP address of the machine and the pipe/pipe name. And this specific name pipe, you need general domain permissions. So you need to be a member of the domain, but this is pretty much it. If you have domain permissions, you can connect to it. And you can see that once I connect to it, if I just send a single character, when I get back to the machine, the program is not responding. And same thing goes for SugarSync. Let's do it once again. This time I'm going to show you how this can be done using fuzzing. You need internet connection for this. Obviously a cloud service. Okay. Demo god almost had me. So here is named pipes of SugarSync. And now I'm going to activate this advanced utility. Just a second. So I'm putting the same IP address /pipe this time the SugarSync pipe. And you can see that only after two iterations only, and program is crashed. And the last interesting thing that we found is that we can actually try to inject commands to the BitTorrent name pipe. So let me connect to it once again. But instead of a single character, now I'm going to put, here you go, Hack in Paris 17, 2 words divided by space, and I'm going to send it. Torrent file Hack in Paris 17 does not exist. So actually you can see that my input is processed. And in this example, you can see that I can try to remotely inject download commands to this BitTorrent client. I can tell him which torrent to go and download. So this is becoming even more interesting. So let's move on to the mitigation and defenses. So the developer's point of view, just know the risk. If you use open source frameworks or like Qt framework or others, if you use named pipes in your application, Windows application, just know that named pipes can be connected remotely. And don't treat it as an internal only interface and neglect security. Always follow the least privilege approach and assign appropriate ACLs. Never just open a named pipe anonymously and to everyone to connect to. And possibly, if possible, just limit the maximum number of instances as well. If you only need one instance, for example, you need one process of your application to connect to another process, just put one maximum instance. The users or third-party software clients' point of view also know the risk. Block all unnecessary SMB and RPC services. If you don't need it, just block it. Segment your network, so at least you cannot connect to each and every station in your network and try to exploit vulnerabilities in named pipes, and always install latest software security updates. The hacker's point of view, well, hack, have fun. This is something that is largely unexplored, so try to perform remote code execution and denial of service in multiple interfaces. To sum up my presentation, Windows named pipes are forgotten, remotely accessible, socket-like interface, a whole newly rediscovered potential world of local and remote vulnerabilities, because no one just knows that they exist, and if you do know it, you don't care because you thought that it is local only. So don't ignore named pipes in your Windows desktop application and stay safe. Do you have any questions? Thank you.